Going into assignment 7 then, exercise 7.17. I picked these for the section views, and this is another one of those. There's a lot of noise. There's a lot of things going on in this drawing, so being able to pick out the information that you need, take it in small segments. Find it interesting the note of maintain the 3mm wall thickness. So as this is coming around, this is kind of an offset through this portion. And then, with the radiuses and coming back up. And then through, that's kind of the hub. And back through. So we're pretty much splitting this. And then we're going to draw the half and rotate. If this was in an isometric view, then we would be quartering it or halving it and then quartering it to get our view. So 3 times 5x10 keyways, so 10 by 10 key stock, equally spaced, 10mm holes on an 82 bolt circle, equally spaced with 3 times. So those don't necessarily have to be clocked. Typically, they don't have to be clocked. In this case, because of the keyways, they may actually have to, may end up having to be clocked because we're getting close to a spline and the positional tolerance. It wouldn't necessarily have to be exact, but if we were putting an 8mm bolt through there, we would have a millimeter either way that so we could look at this from a positional standpoint of do we have to put a tolerance on the keyways to the bolt circle. All right, so location. Let's go ahead and position this out. It is in metric. So new part metric. We're going to go ahead and sketch this in the same orientation on the front plane. So sketch my center line, because this is symmetry or axis of revolution. This is going to be horizontal, infinite length, placing it on the origin. The part, the nose of the pulley, the sheave, is going to be on this face. So I guess with the through bores and the lines, yeah, it's not really going to matter. So we will pick the top part, and I'm going to sketch a couple of pieces of geometry to get it started. And we'll just deal with the hub. So our hub kind of looks like that, maybe not quite like that, but sort of like that, and I missed. So grab the endpoint, drag it to where it's coincident, and that one needs to be vertical. All right, so the end face, that's going to be where I'm going to locate for the origin. So select, control, select, make those coincident. And we have a through diameter of 33, so I'm going to get that one out of the way. And once I go into the diameter dimensions, it's going to stay. So 33 and 43. And then the outside of the hub is 54. All right, I need to expand that out. Maybe not that much. Expand that out to where we can see that then it goes from 54 to 57, and that's determining the angle. This is called a cast steel. One thing I noticed is that they put the grind marks on, so this is sitting inside of whatever is turning. They want a nice surface finish on those, but we're not given a surface finish call out, so I'm not going to worry about those right now. So we go back into the diameter, and once I'm in that diameter command, and you see the little D center line, it's going to stay until diameter until I hit escape. All right, so after I pick the first one, place it on the opposite side of the center line, that puts me into the diameter dimensioning or the full dimensioning. Then I can hit escape to get out of it, and we'll start putting in dimensions. So the step is 21. The angle is 18. see what else we have to work with here. We're not quite past the step. The overall from nose to the back is 62. And then those inside diameters is, we're going to go to 54, so we're not in the diameter tool, so we're going to have to pick the center line again. And then we'll go 54. And from that face then, all right, so we have the 54, but from the back edge to the inside is 29, and we set the 62. So we're looking for kind of a stack up since this is in effect chain dimensions. So we're going to go over, out. Let's see, there's only the one chamfer, the rest are radiuses. Okay, 2 chamfers, and that one's an 3 millimeter, and then the 2x45. So where is the second 2 millimeter chamfer in this? I would think it would be on the back side, but maybe not. Okay, so that's sorry, not 2 times, that is a 2 millimeter by 45 degree chamfer, 3 millimeter by 45 degree chamfer. Okay, that makes sense. All right, so 62 to that face. We're going to go back up and around. And what is that first step? And it comes back. Where is my dimension to that step? So we have 19 there. I don't think we're, no. Oh, there it is, 10 millimeters from there back. All right. So took a little searching to decipher that. All right, so let's do the next couple of segments. So we'll pull that up a little ways. That's probably not too far off. I think, okay, the 21 was the inside step, and the 27. So, all right, so this comes over. Up, and then it's the outside step. All right, so once we get over here and it comes back down, and this one is at a little bit of an angle and goes this way. All right, so, and I missed again. So there we go. And then we'll follow it around this way with, oops, missed. All right, let me get out of that. And whoops, sketch. I was trying to do a thin feature. Got really button happy on that one. Back into control 1 to the front view. I'll pull that out a little ways. I'm going to go ahead and draw the feature in, or the fillet in, and then we'll call that good for now. All right, so I have enough geometry. Horizontal. No, oh, it went parallel. All right, so when it gives me the error and I see the parallel, it actually inferred for that line. So that was not the desired result. All right, so 27 millimeters to the first step, and then 16 millimeters to the next. And I probably could have put that the next line. Oh, I got that to go to a center line. So let's uncheck the for construction. So that means these guys are going to come back a little ways. All right, so the 29 is to this step. And the overall, well, we haven't quite worked our way around to the overall. All right, so we're gonna need that overall. So we have the blend, and then it goes into a radius, and then it comes back and it goes into the angle, and then it goes that way. Ay, ay, ay. All right, so from that point to that point is 72, or sorry, 78. And then from step to the line is the 29. And then this one is the 10. Okay, so kind of expecting that to be a little strange. All right, so to our points, as we're still deciphering this thing, we're 190 on the outside. And since that goes right into a fillet, I'm going to go ahead with the point. 190, so that's quite a bit bigger. What else am I missing for the diameters? So the outside hub on that 16 millimeter is 114. I'll kind of leave that one where we can get to it. $114, and we'll come back. So this was 3 millimeters by 45. Okay, so those are starting to come in. Let's see, what else do we have? The hub, we did it 54. And so let's double check that I did that correctly, because I think I got another step in there. All right, so deciphering it that way, I was thinking that that step was part of this, but since it's not, we'll delete that segment, and that comes up, and that goes coincident. So that makes the interior hub. Okay, so coming around and over a little bit of an angle on the step. Oh, too much. All right, so to the point, to that intersection was 95, and I'm not going to worry about any more of the fillets because, well, this just became complicated enough. The fillets and rounds. We have a 30-degree angle, so here's where we can go the endpoint and the line, and pick the four-headed arrow that goes in that direction, set the 30 degrees. All right, and then the next step, if that maintains the 3 millimeter wall, then we're going to have to construct the V to get it into position and come up with that angle. So since that's at 30 degrees, then technically that should be at 30 degrees. And now you know why there are only 3 exercises in this assignment. So let's go to the tangent arc, and we'll come off of that way. And then we'll select out of it. I'm going to hit L on the keyboard. And we're going to look for parallel. So I kind of hover over that and it flashes up the parallel. We'll go into a continuous, to the continuous tangent arc and pick up that point. And that should not be vertical. So that means I'm losing the tangency a little bit. But while I'm here, I'll go ahead and select. All right, and these are going to be symmetrical on the lines. So let's go ahead and put in a 30 degrees. So actually the 30 degree half angle would be 15 degrees. So let's just put in a center line. So as soon as I put in this second center line, and that's going to help me with my symmetry, we're going to make those parallel. And then for length, we'll go with horizontal. right? And then the lines can become symmetrical. So select, control, select, control, select. Hold that up a little ways. All right, so we have a radius of 3 in the bottom. And since the upper fillet moved a little bit, that tells me that I didn't get tangency. So we'll go back and apply tangency. And actually, since those, well, I don't know that that'll be exactly the same. So we have the tangent arc. I'm going to come off of that. And even though I can't say that they'll have the same geometry, they will be equal. And then we'll come off horizontal, and then we're getting a lot of geometry, so we're going to get a lot of inferences. So just be careful when you're placing that, placing the line, that you're not inferring something that you don't want to. All right, and then this is also the same diameter, so we're going to go coincident, selecting the point. All right, radiuses of 3 at the end, so let's just go ahead and make all of those equal. All right. Positional, it is 19, and that looks like, I want to say it's 19 to the top of the vertices. Most of the time, since I included those, we're going to need some virtual sharps. I'm not going to count on it being the lower portions, because that, I wouldn't call that a good design technique. I can't measure those, and if I'm going to machine this with a form tool, I may plunge it with the 30-degree angle in the nose. I may plunge into that material, and then wouldn't be 100% sure what the position. But they are going to say the 3 millimeters on the vertical, and then once we apply that, well, I think it is dimensioned from those points. But let's talk about a virtual sharp real quick. If we need to dimension to those points, I'm going to select, control, select the lines, and when I hit point, it's going to put an intersection up here. And that intersection, let's see, will it go with that one? Probably not. All right, so I need the line, and we need either a construction line or something out here. No, is that going to give me a virtual sharp? No. So it's not liking the points. So in that case, my virtual sharp, and we set the look of these in the options. So that needs to be coincident, and then that one will be horizontal. So we can, if we can get the virtual sharp, otherwise we'll set the points, and we'll see how close that ends up being. So I'm going to get rid of the virtual sharp, and we'll stay consistent with the points. But in the drawing, I would probably put these over into the points. All right, so we're going to go. Best guess is to the bottom of the radius, which I don't think is, I don't feel like that's something I can measure. We want to pick the line, since this is we're given the 3 millimeter wall thickness. We're going to go to the arc and then accept it, whatever the dimension is. And because we picked on the arc and not the center point, I don't have to do math. I'm going to switch to a min condition, accept the dimension, go back and double click, 3 millimeters, and then that sets the wall. Okay, so as far as that one, and we're also going to maintain 3 millimeters here. So between our parallel lines, then that starts to come together. All right, so 6 millimeters on the interior, 3 millimeters, 3 millimeters. Yeah, we're going to do those as separate fillets. I've already made this complicated enough. All right, now we're at a point where we can connect the endpoints. Actually, there is a fillet on that one. That was let's see, we put to the outside, the step. Okay. Let's pull that back up and we'll see where, okay, so we have the 3mm by 45 here. And then we come down and then that's a sharp and then that's a sharp. Okay. Got it. So I'm going to pull up till I see the inference line. The other thing that we could do is go ahead and select both endpoints and tell it to merge. It has the same net effect. Merge does not produce a relation just like any of the other endpoints. We have the distance, but those are coincident. We'd either have to trim or split entities to break those out. So I'm tired. Let's go ahead and revolve this and see what we get. So the revolve boss base, it's not going to show me a preview because I put in that second center line. So the axis of revolution that I want to revolve around is that one. All right, so we have our chamfer was on the interior on that one. I'll include it afterwards. And now we can go pick up the radiuses. All right, so the internal radiuses are radius of 6, radius of 6. And then the insides are 3s. Oh, the keyways. Well, let's do the radiuses and fillets last. I want to go ahead and put the keyways in the holes. So let's go ahead and select. Yeah, we go on this side. It looks a little bigger. So 3. Okay, hit everything except control 4. So there we go. All right, so 3 times equally spaced. It does not say that the holes and the keyways are clocked to each other. That would be a consideration. It just depends on if the bolting plate is going to, whatever this is bolting to, is part of the shaft and the flange. All right, so sketch. When we do the keyways, we can go with a center. If we just do the corner, then I'm going to select for the midpoint, make it vertical to the origin. Going to set these equal. It said it was a 5 by 10 keyway. What that does then is I like to see this in terms of the 10 by 10. We could also do it as the 5 by 10 and then pick up, but this also gives me a visual reference of where the keyways intersect. All right, so then I'm going to select the midpoint, and the midpoint is coincident with the circle. All right, so that puts the center point just a little bit off, but by the time we do the tolerancing on all of these, we'll be right there. So our objects, I'm going to go ahead and select chain, and we're back in the sketch. We're going to circular sketch pattern. I've not generated any geometry, so we're going to go 3 instances. Let's tell it to go ahead and dimension the angular spacing, and we'll accept. So it's at 120, which is kind of a weird way to pick the corners, but all right. If I drag off the center point, there's my center and my angular. So if I drag it back to the origin, that should get me fully defined. Linear and circular sketch patterns a lot of the time will require one more drag or placing of a relation or dimension to get it to go fully defined. So features, extrude cut, we'll go with the through all and accept. All right, so we put those in, and then let's go back to the 3. If we were going to turn this into a counterbore or had to do anything with the hole wizard, then I'd want to be on this face as opposed to the interior. Pretty sure it's going to bolt from this side. Well, I say that and then I don't know. All right, so if we have to change it, we have to change it. I do want to use the hole wizard for the geometry. and we're 10 millimeters through. Oh, I rotated the mouse at just the wrong time there. So drill sizes, and then we're going to, okay, my scroll is jumping around a little bit. We're going to go through all. Maybe I shouldn't use the scroll wheel on this one. There we go, 10 millimeters. And the position. And it's without the side view. Then we're pretty much guessing anyway, so let's go ahead and place these. I'll generate my bolt circle. And I'll go ahead and make it for construction. The hole wizard doesn't really care if it's for construction, but the other standard cut extrudes do, so just a good habit to leave it as a construction. And go ahead and make that coincident. I'll drag that one out and it'll find coincidence. So for our smart dimension, I can put in the construction line and dimension the other points to it, but we have another type of angle dimension where I can pick the vertice, the endpoint, and the endpoint, and we'll tell it that it's 120. And then the vertice, the endpoint, and 120. Okay, we'll go ahead and accept those. All right, so if I do need to change those to countersink, just like the others, we may end up with an error if I have to change it to the interior. Well, don't think we're going to change it to the interior if it's that close to the angle. So whatever is going through is coming through from this side, and it's bolting into the flange or the mating flange there. So if I needed to change it, though, I would edit sketch 3 and change the sketch plane to the interior, and then we could put our counterbores or countersinks on the other side. All right, so whatever the stack up is, we're still in question, and I may have, based on the definition, I may have clocked it anyway. But if I do need to change, and it's giving me the warning, so let's go ahead and save the document. This is 7-17 or 7.17, the sheave, and my initials. Oh, we're in assignment 7 now, so we'll go up one, new folder, and save. All right, so that leaves the chamfers and the fillets. So while we're looking at this side, let's go ahead and put the chamfer on. This one was 2 millimeters by 45 degrees. So I can double click in the box. 2 millimeters, don't know why it's giving me 8 decimal places, but it is. We said that these two are 6 millimeter. So if I click on the face, we're going to try it this time. Preference is to pick for edges, but we will see what it looks like. So double clicking in the box, 6 millimeters, and we'll see what kind of blend we get. That's a little bit close. So Fillet Expert pops up and says it has to do a little deciphering there. So since it's a radius into a radius, it may end up being 2 fillets, or we'll have to go back and find the blend. So it is to the flat and then a little bit of a blend. Since I added the holes, I do not want the holes to be filleted, so this one now goes to edge, to edge, and fillet of 3 millimeters. All right, and then where it goes through the holes, that really looks just too crazy close, but we'll give it an okay, and it's going to find the blend there. So maybe there's something that's locating, but those are those are concerns. So my questions for the design review to highlight are going to be, in this case, the, well, since it's all 3 features, let's see if we can do that as the cut extrude. So when I go into the appearance, we're just going to select the feature. The body would still be everything. I'll highlight that. And then appearance for the whole. Let it catch up here. Again, for the feature, first is the whole locations. Are they too close to the edge? Do we need to look at the mating part? And then, does it need to be clocked to the keyways? All right, so we'll go ahead and save one more time. Let's take this into an Assignment 7 drawing. Since I didn't say it first last time, I'll say it first this time. Is the drawings are still optional. These are for your reference. And since this one is, now they're going to switch back and forth. So I'm not concerned about the inch and millimeters at this point. We would have to decide ultimately, but yeah, okay. And so the main thing here is just to show the section views and being able to manipulate this geometry, being able to recognize it. If you're going to be focusing on drafting detailing, then take the few minutes to go through and build these out with the drawings. All right, so I'll go with the front view, which is what we cut. And looking at that, I'm probably going to need what would be the back view. So let's go ahead and create those. In fact, I haven't been using the feature palette or the drawing palette. So let's pick the view palette. It'll show me the previews. I'm not going to pull as much geometry off of the front view as I am the right view. So I don't really like that as the isometric view. Well, that one's not doing anything. All right, so we have some weird isometric views. Oh, it's showing it as the back too, so that makes sense. Let's change it. So even after I've selected the view palette, I can switch it. All right, I'm happy with the front view. That's going to be the center mark is, oh, and since I didn't save this to save my my layers to the sheet format, I'll have to recreate them. So let's take care of that real quick. I'm going to open up a new real quick. All right, so with the new sheet, we don't want to insert anything. We're going to, oh, well, there's the layer there. Why didn't that show up on the other one? Oh, we turned it on. Okay, get back into the mix. We turned it on, but the toolbar on, but we didn't actually add anything and keep it there. So new. I go with the dims, whatever you decide to call it, just call it that on everything. So we'll set the color, and then we need a new, I'm going to call it the center. And then, oh, this one was kind of the magenta looking, and then we'll hit OK. And then I'm pretty sure it just goes for the document template. It's not going to be for the sheet format, so let's go with drawing templates. And we'll have it navigate to the A size and save. And yes, replace it. All right. And so we still didn't get this one. Well, let's go ahead and kick that out. I want to double check it, so you can go ahead and fairly easily just build those two, but they're center. So unfortunately I saved it with the center, which may not be a bad thing since when we insert the parts they come in first on center. So all right, so we actually we drew on the right plane, so the left is going to, I think it was the one that we wanted. It comes in with the center mark. And then I'm going to switch over to dimensions, because pretty much everything else will be for dimensions. Didn't really like the isometric view on that one, but we can go up to the view layout, pick our projected view. All right, that looks pretty good. Let's set a little bit bigger, so 1:1. Okay, way too big. Half. And then we'll switch over to custom scale. That one can go back to 1:5. All right, and there again, the half scale may be a little bit big, but since we're on the sides, we won't, not going to worry about it too much. So section view, we want to see what this thing looks like going down through the middle. All right, so the first one will just be, and we're not doing any alignment, so we'll bring it out to the side. All right, and based on folding that up, I don't like the direction, so if I double click on the A, I think it's double click on the A. There it goes, and then rebuild. That'll make it to where it folds up. All right, and then it automatically puts the hatch in. So the cross hatch for the pieces, and then this is a little confusing. It's kind of hard to tell, if that's what the intent of the drawing was, that the keyways were going kind of through. This one went through, so that's why it's still a question. All right, and then if we wanted an aligned view, we go into section view, and then we're going to hover over these, so that would be a horizontal. That one is an auxiliary view, so if we came in at some angle. And then the aligned view, we're going to pick the first one, set its angle, so that's vertical, and then I can bring the other one over, and we'll see if we can get coincident to the whole location, and accept it. And now that kind of cleans up the interior geometry, and we see the two holes as going through for B. So let's see, if we reverse B, that'll make it to where it folds up a little bit better. Am I still in the command? No. All right, let's highlight. All right, so if I can't flip it that way, we can always select the view and come over to our view, reference, and the arrow. Oh, so the arrow directions, if we want it pointed to. I was thinking that there was a way to reverse it over on the profile. So view scale, oh, that's for the isometric. We're just overlapping a little bit. All right, so that gives us the start. If I pick a cylindrical, then on the annotations we can put in a center line. And, oh, well, let's just select the view. Okay, so that puts in that one. Since I already changed over to dim, it puts it in as dims. So we'll switch that over to center. Okay, so that looks a little better. And we can do that again if it's highlighted. Select view. Places it. That one has a few more. Oh, I missed that one. And then we'll switch those over to center lines. All right, so then from there we can put in our dimensions. So pretty much to the outside. All right, so since that didn't go to diameter, let's try, see if it's going to let me do it on the section view. All right, so we just pick across. So center line's not the same functionality as what we were doing in the when we're creating the sketches. So it is pretty good size. Probably need to shrink the center line a little bit. All right, and then we'll just put a few dimensions on for reference and go ahead and save this. And notice that it reverts back to the location, so we need to, find my library and assignment 7, and we'll just make this Assign7 in case we want to do a couple more. All right, call that good.